Imagine a world where nothing is truly fixed or absolute, not even the ticking of time or the vastness of space. That's the mind-bending idea at the heart of Carlo Rovelli's work, and it's enough to make you question everything you thought you knew about reality. But here's where it gets controversial. Rovelli suggests that what we call reality might just be a collection of perspectives, leaving us to wonder if there's any objective truth at all. Dive in, and discover why this physicist's views could reshape how we see the universe, and ourselves. Carlo Rovelli's Radical Perspective on Reality. Quantum Magazine. The theoretical physicist and best-selling author draws inspiration from politics and philosophy to rethink the very nature of space and time. Introduction. Picture this: lounging outside a quaint Catholic church on the sunny French Riviera, Carlo Rovelli mimics the quirky head bobbing of a nearby pigeon. He explains that these birds don't just do this to steady their sight, they also use it to judge distances to objects, making up for their limited ability to see in 3D. It's all about perspective, he says with a grin. As a theoretical physicist linked to Aix-Marseille University, Rovelli explores how our human viewpoint shapes our grasp of the world. His work spans quantum information, black holes, and even the history and philosophy of science. Back in the late 1980s, he co-developed loop quantum gravity, a theory that tries to explain the quantum building blocks of space and time. Then, a decade later, he introduced a relational take on quantum mechanics, boldly claiming there's no objective reality, only viewpoints, whether from a scientist or that same pigeon. Lately, Rovelli has become a household name through his popular science books, like 7 Brief Lessons on Physics, which has sold over 2 million copies globally, thrusting him into a spotlight he's still navigating. "I'm terrible at fame," he admits. "I keep landing in hot water." During our chat, he was defending himself against backlash from the head of Italy's Physical Society, who accused him of unfairly painting Enrico Fermi as a bloodthirsty fascist/Nazi. Rovelli's fresh outlook on physics stems from his rebellious youth. As a student protester during Bologna's 1977 political upheaval, he ran a clandestine left-wing radio show, penned an illegal pamphlet, and refused military service, landing him in detention. Disillusioned with society, he felt we were all muddled about reality. At 69, he's still politically active, and fired up. "Part of me is that old hippie." After the Bologna turmoil faded, Rovelli channeled his skepticism toward the core of reality itself. He applied his knack for questioning norms to tackle deep issues in physics, not by ditching proven theories, but by flipping our perspective on them. His method embraces ditching old assumptions about how the world operates. To combat his own biases, in science or society, Rovelli leans on philosophy. He frequently writes on metaphysical topics and pushes for more crosstalk between fields. His latest book, just out in Italian, dives deep into where philosophy and physics meet, a blend he believes unlocks what our theories truly reveal. Quantum Magazine caught up with Rovelli at his cliffside home in Cassis. Over a leisurely 12-hour discussion, spanning his patio, local strolls, and a cruise on his century-old sailboat, we chatted about religion, war, consciousness, media, love, pigeons, and, naturally, physics. We've condensed and polished the interview for clarity. What is your central question, and how did it lead you to study quantum gravity? My big question has always been, how does everything truly function? We've got 2 powerhouse theories that excel in their realms, general relativity and quantum mechanics. Learning them as a student blew my mind. They shatter core ideas like space being an empty backdrop for things and time as a straight-arrow march. They echoed my belief that to really grasp reality, you've got to be willing to go extreme. Attempts to debunk these theories have all flopped. Yet, there's this glaring hole. Phenomena like matter plunging into black holes don't fit either framework. Merging them sparks contradictions and paradoxes. For me, bridging them, the quantum gravity puzzle, highlights a major void in our understanding of the universe. Tell me about the approach you've taken to fill that gap. Loop quantum gravity. Loop quantum gravity takes a cautious path to a wild outcome. It says, Let's fully embrace general relativity and quantum mechanics and follow them wherever they lead. No added fields, particles, or tweaks to Einstein's equations, just making sense of what we already know. Essentially, it proposes space isn't endlessly breakable, it's built from tiny building blocks connected in loops. The math is straightforward, but it ditches time and space as basics. Instead, they arise from how these gravity quanta connect and shift. Space equates to the number of loops, and time to their gradual changes. How do we account for our common experience of time if it's not fundamental? Our sense of time marching forward stems from the second law of thermodynamics, the push for systems to grow in disorder, or entropy. But this feels fundamental only from our angle. We're tied to large-scale factors where entropy rises in one direction overall. I suspect the whole time flow is like the daily sky spin, grand and vast, but an illusion. This perspectival view makes the second law real, like the sky's rotation, true for us, but not universally. One critique of loop quantum gravity is that it contradicts certain predictions of Einstein, namely that the speed of light is constant for all wavelengths. What do you make of this critique? The theory has advanced greatly in the past 2 decades, and today's version aligns with Einstein's ideas. The light speed stays steady across wavelengths. Still, challenges remain. We're unsure if different theory versions match up. Particle interactions might produce endless low-energy radiation. And solving the equations is tough, we're simplifying it. The biggest hurdle? No experiments back it up. But optimism brews. Proposals suggest it could explain oddities in the cosmic microwave background from the Big Bang. And I'm thrilled about another idea. If correct, there might be minuscule black holes, weighing 10 micrograms, long-lived and only interacting via gravity. We could detect a wind of them. Maybe these are dark matter, that puzzling cosmic stuff we can't pin down. Detection's tricky, but not impossible. I hope experiments will convince the field that loop quantum gravity fits naturally. It's unclear we can't explain everything with century-old theories that have worked wonders. And this is the part most people miss. Clinging to these theories might keep us blind to new insights, sparking debate on whether progress requires radical rethinking. If we are to hold on to our existing theories, what picture do they paint about the nature of reality when taken together? Rethinking space and time flipped my view of reality, from a cosmos of defined objects to a web of interactions. This relational quantum mechanics builds on relativity and quantum theory's trend toward perspectives. We're familiar with relative speed. This table's velocity differs from my view, a pigeon's flight, or the sun's. Einstein relativized time and length. Relational quantum mechanics goes further. An object's traits, color, position, size, are only meaningful relative to another system. We must abandon things observed externally. Modern science best describes reality through how parts of nature relate informationally. We only perceive the world from our limited, biased standpoint. This shakes things, as we can't list absolute world elements. We must accept an incomplete reality picture. There's something unsettling about this argument. It seems to undermine the ultimate goal of physics to describe the true nature of reality, does it not? It does, but science's goals have evolved, from celestial motions to particle forces to field dynamics in spacetime. I see science as finding the best framework for nature as observed. The relational view acknowledges our limited knowledge and partial views. It offers a stronger, honest reality approach, ditching the myth of ultimate truth. Don't mix our knowledge with the world's actuality. If this feels empty, that's understandable. But recognizing limits enables learning. Between certainty and ignorance lies our fascinating reality. You've written about how your change in worldview has been guided by philosophers. How do you view the relationship between philosophy and physics? They need each other desperately. Philosophers ignoring science miss key knowledge, silly. Scientists shunning philosophy get stuck in outdated thinking. Historically, ties were tight, all major science shifts drew philosophical influence.